第44集电荷之战。
Hello, Meng Meng. That's an interesting look.
嗨，克里斯博士，我来给你表演一个神奇的魔术。这个魔术叫魔法气球。我的气球有一双看不见的手在拽我的头发，我的头发都立起来了。你看到了吗
Yes, it's quite obvious. Where did you learn that from?
我就是用气球在头发上蹭一蹭，然后就有魔力了。
Brilliant. Do you know what's causing it?
完全搞不懂，太神秘了，一定有一种看不见的魔力。
You're right. It's a kind of force in physics. Do you know the name of this force?
它和地球引力很相似，难道是引力吗？克里斯博士
No, not gravity. Let me give you a hint. It's the same force that causes the lights to come on, and the same force that gives you a shock when you touch a doorknob.
我知道了，是电老虎，对吗？
You got it.
可是等等，电是从墙上、金属电线之类的东西上来的，不是从头发和气球上来的呀。
Haha. Well, it seems you've forgotten some knowledge from our last lecture, haven't you, Meng Meng? In fact, electricity is all around us. Like all sciences, physics teaches us about the world beyond our senses and everyday experiences. It's the same with electricity. It's more than just wires and power outlets. Now, do you remember what causes electricity?
我想起来了，是不是原子家里的电子和质子打架产生了电呢？
Close. Electricity is caused by moving charges, and those are caused by electrons and protons. They
对，电荷有两种，正电荷和负电荷，它们最爱打架了。它们总是骑在电子和质子身上，互相打架，要打败对方，对吗？
Right. And do you remember which charges the electrons and protons carry?
质子携带的是正电荷，电子携带的是负电荷，对吗？
Yes. An electron has -1 charge. We use +1 charge to represent the proton charge. And similarly, we use -1 charge to represent the negative charge.
减一电荷，减一是负的，可是为什么要用加和减来表示正电荷和负电荷呢？这是不是意味着它们在一起就会相互消灭对方，然后就变成零了呢？
Good question. An electron charge cancels a proton charge. So, if I have one electron and one proton on my hand, they cancel out and I have no charge. The +1 and -1 lets us use math to do the counting for us.
好吧，听起来挺有意思的。不过这有什么用处呢？还有，我的头发到底为什么都站起来了呢？
All right, I forgot about that. Well, now that we know about charges, we can find out what they do. How about you? Would you like to know? Great. Come on. Hi, children. So we know that electric forces are caused by charges. We have positive charges and negative charges.
还有，它们都躲在质子和电子里。
Yes. And the atoms that contain protons and electrons are everywhere. So charges are everywhere. On you, on me, and on this straw.
难道他们在哪里都在打架吗？
Yes. Do you remember how to perform the cancellation of charges?
你是说他们战争的结果吗？我记得这都取决于数字。如果说电子的数量多，就是负电荷赢了；如果质子的数量多，就是正电荷赢了。
Yes! Each positive charged proton will cancel one negative charged electron. If there are more protons than electrons, then my straw will have a positive charge. But if there are more electrons than protons, what will the charge be?
如果电子多的话，那留下来的就全是负电荷的队伍了。所以吸管携带的也是负电荷。
Exactly right. No matter which charge an object carries, either positive or negative, the object is charged, just like my straw right here. And we can charge it as well. Kids, did you play the game I left you with last time?
我玩了，只要稍微摩擦一下，吸管就带电了，真的很神奇。
Correct. In fact, when I rub the paper on the straw, it adds electrons. This is just like the electron troops getting backup support, and the electrons increase. So now this straw is charged. It has a negative charge.
哇，帅呆了！那你怎么知道电荷是不是要打仗了呢？这好神奇啊！
Ah, so you want to know the secret of the electric force? Well, it is quite simple, really. That is because positive charges only attract negative charges. So, if the charges are opposite, there's going to be a battle.
你是说有负电荷的电子只会找有正电荷的质子打架？那这是不是就意味着，如果这里已经是负电荷了，其他的负电荷就不会再过来了吗？
Sort of. In physics, when two things have a charge, they either push or pull. By pull, we mean they come together to fight. And push means they need to keep their distance because they come from the same troop.
好吧，我明白了为什么吸管会被推开和吸过去了。但是这种情况下，我怎么知道究竟哪个部队遇到了哪个部队了呢？
I'm not sure what you mean.
我们做第一遍实验的时候，吸管吸到了一起；做第二遍实验的时候，它们就分开了。当它们相互分开时，是正电荷遇到了正电荷，还是负电荷遇到了负电荷呢？
Oh, I see. That's the right question to ask. Let me explain. Kids, do you know how many possibilities there are? Let me show you. Children, a charged object, like a straw, can be positive or negative. When we have two objects, there are 4 possibilities. That is to say, the charged troops on each straw come together and lead to 4 pairs of possibilities.
4种情况。
That's right. If we represent red for positive charges and blue for negative charges, then there are 4 possibilities. The first is that both could have positive charge, or the first could have positive and the second negative, or the first could be negative and the second positive, or finally, both could be negatively charged.
真的是4种情况，但是这4种情况下的电荷并不是都在打架，对吗？
Right. The confrontation under these situations can only lead to 2 results. They either come together and fight, or push apart and keep their distance. That's the rule of charge.
电荷的定律，那是什么？
So the rule is this. If the charges are the same, they push away from each other. And if the charges are different, then they pull together.
我明白了，就是相同的电荷部队就离开对方，保持距离；那些电荷不相同的部队就会抱在一起打成一团。
Very good. I'll give you an A this time. But let's test your knowledge. what would happen if both straws had extra electrons?
电子带有负电荷，所以两根吸管肯定都携带了负电荷，它们都是负电荷部队。
That's right.
然后根据定律，带有相同电荷的物体会相互排斥，自己人不打自己人，所以说吸管会相互排开。
So clever. But what if one straw has extra electrons and the other straw has extra protons?
这简单了，克里斯博士。质子携带着正电荷，是正电荷部队，所以一根吸管携带着负电荷部队，另一根携带了正电荷部队，那他们肯定会打架的。这就是力会将他们拉到一起去的原因。
Wow, you really are becoming a fast learner. But are you ready for the trickiest question yet?
准备好了，我是所向披靡的。
Okay. What will happen if one straw has extra electrons and the other straw has equal number of electrons and protons?
我觉得我不是什么都会的。
It's okay, Meng Meng. It was a tricky question. I think we should do some more exploring to get to the bottom of this one.
玩游戏。
Let's play.
亲子游戏。
Children, today we learned about the causes of the electric force that pushes and pulls. Remember, if the charges are the same, they push each other away. And if the charges are different, they pull each other in. And if neither object has a charge, then nothing at all will happen. In that case, there's no electric force. However, if one object does have a charge and another object doesn't, then something will happen. And we've already seen this. Do you remember when you charged one straw and not the other? What happened? They pulled together. Let's see some more examples of this. Take out your straw and your paper and give it a good charge. Find some things that you can pull with your charged straw. My favorite is a stream of water. Watch this. Why don't you try to find some more things that you can push and pull and charge with electrons? Have fun!